So what is functional programming anyway? It has functions in the name, so probably has something to do with that. One way of thinking about it is to say that a language supports functional programming if it has first-class functions. A type is first-class in a language if we can declare values of that type, variables of that type in any scope, if we can pass these types around, these kinds of values around, and if we can return them from functions. We've already seen some functions that use other functions as parameters. So we saw for each and map and filter. These are all higher order functions because they take functions as arguments, functions of functions. It's also really common for functions to return other functions, and we'll look at some of those now. To warm up, let's look at the standard definition of add. Here's an add method that takes two parameters and adds them together. When you invoke this, you use the pair syntax, and add takes the pair and adds it up. Add is a method in Scala that takes a pair of ints and it returns an int. We can also write this in a different notation, which is called currying. Here we write the method, instead of using a pair of arguments, we use two separate arguments. And that's reflected also when we invoke the method. This is a method that takes an int and returns a method that takes an int, and finally will return an int. And you can see this reflected in the type that Scala gives this method. So note that it's not accepting pairs and giving ints, it's instead taking integers and then returning a method. Scala has functions and methods. And this is because it is both a functional language and an object-oriented language. And we'll see more about different ways to integrate functions and objects in later lectures. But for now, it's sufficient to just understand a little bit about how they work in Scala. In Scala, in addition to declaring a method, I can also write down a function. Functions are written in this lambda notation with the fat arrow. This add3 is a function that takes a pair and returns an int. And you can see when I declare it in Scala, I have a value. This is not a method, this is actually a first-class value that I can store somewhere. Note that methods aren't really first class. I can't pass a method around without somehow involving its object. But functions are first class. I can store them in values and I can pass them around. So this is a function, again, that takes a pair of ints and returns an int. Just like I can curry methods, I can also curry functions. The notation's a little bit different here. I use the fat arrow twice to say that I would like a function that accepts an integer and returns a function that accepts an integer and returns their sum. The invocation syntax is identical to the invocation syntax for a curried method. But what's happening here under the hood is a little bit different. This is a function that takes an integer and returns a function. We can also write a method that returns a function. Add5 here is a method that takes an integer and returns a function that expects an integer and returns their sum. And the type you can see here is a little bit different than the type you get for add2. So this is the type we had for add2, and this is the type for add5. It's interesting to note that these compile to the same thing. The code, the binary code that is produced by add5 and add2, it's identical in the current Scala compiler. The difference here is how these things are handled in the language. They do have slightly different rules in terms of how you can apply these things. We can take any method though and explicitly convert it to a function in Scala. And this is done by taking the method and putting an underscore after it. This is actually a different use of underscore than we've seen before. We've seen two uses of underscore already. One is in patterns. We can use an underscore to mean that I don't care about that variable and it doesn't get bound. We've also seen that in expressions, I can create anonymous functions very easily using underscore and use that instead of a lambda expression. This is yet another use which will convert a method into a function. So you can see here add1 and add2 are methods, and when I convert them to functions, they convert as you would expect. So add1 here takes a pair of integers, and that turns into a function that expects a pair. Add2 was a curried method, and when I convert it, it becomes a curried function. In certain contexts, Scala will automatically do this conversion. And so it sometimes seems like methods and functions are the same thing, but they're not. They're under the hood. Scala's converting when necessary. If a function is expected and a method appears, sometimes it'll accept it and it will perform this conversion. Scala supports partial application for methods and functions that return functions. So here I have add4, which is a function returning a function, and add5, which is a method returning a function. And in each case, I can apply the method or function to one of its arguments, and what I get is a function. That function can then be applied to the second argument, and I'll get the result that I expect. So this is what's called partial application. My function body here uses two parameters, but when I invoke it, I'm only applying one of those initially. That then gives me a function, which I can then do other things with. I can store, I can pass around, and I can use that function later. Partial application doesn't work so well with methods or with non-curried functions. In these cases, in order to get the effect of partial application, you have to use a lambda expression. Note here on line 12, I can take all of these resulting functions and put them in a list. What I end up with is a list of functions. And note the type here. I have a list of functions. This is not a function over lists. This is a list of functions. What I can then do is draw from that list. So for each function in the list, I can apply the function to some argument, yielding the result. In this case, I have a bunch of functions that have an 11 sitting in them, and they're waiting for their second argument to add in. So each of those functions, when applied to 21, will give me the resulting sum, 32. Currying is quite powerful and quite general, and therefore many of the built-in functions in Scala prefer the curried format to the paired format. And you can see this, for example, in fold left and fold right. If you recall, fold left is a curried function, so it takes its arguments one at a time. It's not taking them as a pair. This allows for more flexibility in using the functions. So I've showed you a little bit about functions and methods in Scala, but there's actually quite a lot more to it. On line 1 here is a definition of a method. On line 2, you can see the definition of a function. But indeed, functions in Scala are really just objects. So I can also declare a function using the function constructor. And functions in Scala are also related to the case statement. So when I use a case statement in Scala, what I'm actually generating is a partial function. So all of this gets a little bit complex, but for now I just want to point out this dualism between objects and functions. Note again, I have a list here. I'm going to coerce the method A to a function, and B, C, D are already functions. I can put those into a list, and what I'll get again is a list of functions from integers to integers. Note that they're displayed slightly differently depending upon how I create them, but they have the same effect. And what this will do when I apply it to 4 is to give me 5 in every result. So def is used to define a method in Scala. And recall that with def, you always must put the parameter types explicitly in your declaration. The fat arrow is used to define a function. And there, it's possible that the parameter types might be inferred by Scala. Functions are implemented as objects with a method named apply. And for any expression of function type, when Scala sees the expression applied as a function, what it does is it simply converts that into an invocation of the apply method. Scala has both methods and functions in Scala are first class. They can be passed around and stored in objects. How does Scala realize that? It implements functions as objects that have an apply method. In subsequent lectures, we'll talk more about the mix of object-oriented and functional features in various programming languages.